So those are pictures of YubiKeys. And they're a pretty cool device. They generate one-time passwords, so that's one way they're used a lot. And then these are the Neos, so they actually double as OpenPGP smart cards. So they can store and manage a 2048-bit RSA key pair that you can then use for GNU-PG, which is something we may get into a little bit later if time allows. So that's not the first part of the presentation. So that's one tool that I can recommend to any of y'all to know about is GPG. So my name is Frank, and I work here in Atlanta with a company that I started, and I have a few other developers who work with me. Brandon Case is here, and thanks for coming. And the other guy we work with is up in Nashville, so it's a little bit of a drive for him, so it's all right. So anyhow, who here has heard of the term data breach? And has anyone heard rumor that something like 1.2 billion passwords were disclosed in the last week or compromised? Well, there's some uncertainty as to the veracity of that particular incident. But it could be true. It may not be true. But there have been big password breaches before. So one thing to think about in that terms is why are hash password compromises such a big deal, even? Not just plain text, but hash ones. And it's because people, by and large, pick really crummy passwords. And they use the same one on every site they visit. So if you have even a properly maintained database, but someone's password is 6 characters long, they're going to be found out just by brute force, and then the attackers can sell and use those on all the other sites. So that's why protecting this information is so valuable. And one trick I will tell everyone here that you should remember right away. If I ever set up Devise on a server for user authentication, I always go into the initializer, and I always change the minimum password length to at least 10. Users love me for this. I get to actually respond with, that was a security decision, won't fix, to the bug reports. But it is worth it, because anything less than 8, and you're in the realm of there is no security in that password at all if it ever comes under attack. And really, it's only after you get past about 13 that you start having something that is worth discussing. So I asked a question on Twitter, like, what do you want to know? And Andy came out with a great question. Is Ruby on Rails secure? And I said maybe. So hopefully by the end of the talk, everyone here will have a little bit better idea how to think systematically about security and understand why that's not a simple Boolean, yes it is secure, no it is not secure question. And Rails is actually a very good framework for developing secure systems. But I use the word system. It's not an application. It is the totality of this business application or this infrastructure that you have built. And that includes all of the layers from your application to the database to the worker nodes to everything. And more importantly, into the business model of the startup itself. And we'll talk more about that. So when anyone asks you, is such and such secure? These are 3 questions to memorize because they can make you like $300+ an hour just by asking these things. And it is really secure against what? Like, okay, sir, what are you concerned about this being secure against? And you listen and you take notes. This is called being a security consultant. And then you say, okay, let's assume that the worst thing happens. What's the result of that? Well, we go out of business, we get sued into oblivion, the CTO goes to jail, like bad stuff. Okay, so now we have an idea of what the result of a problem is. Or nothing, we're really embarrassed and we have to apologize. But that's the reason you have to pull this out is that security is all about countermeasures and a number of them. Anytime you develop an application, I like to always talk about the defense in depth strategy the written information security policy that actually takes its forms as the user story writing workshop is going and continues on through deployment and DevOps and the customer service team understanding that people might call them up and pretext their way into information. And so it's holistic. There's no run this code or install this Brakeman gem. Brakeman's great, but it's one tool in the chain, in your tool chain, that helps you run a secure application development process that has to live in an organizational framework that has this as part of its thing. And compared to what alternative? Let's pretend Rails wasn't secure. Okay, let's say, because there could be another YAML parser vulnerability. Maybe we're afraid of that. Well, ask compared to what? Compared to Bob's handwritten PHP code? So these are balancing acts to understand. So let me do a brief aside first and talk about API tokens. I want to give you all something technical before we get into this high-level, almost academic part of this. Who has ever implemented a JSON API that, like iPhone apps or something, had to talk to? Awesome. Lots of people. Was that an authenticated connection? How did you do the authentication? OAuth, that's a good one. Anything else?
HMAC.
That's another good one. So, yes, those are different protocols for doing. The OAuth is probably closer to what I'm about to talk about. But a lot of times people give you an API token and say, use this token. And often it looks a little bit like that. Does anyone know what that actually is, though, that number? It is a UUID. That's awesome. So does a UUID make a good security credential?
For the hacker.
It's a trick question. But you can get them like this. They're really good. They're not going to get regenerated, likely. And again, they look like that.
It's one time, like a password, right?
Yeah. Well, how do you store it to verify it? So if you were going to take this value, well, let's first go here. The RFC itself says don't use a security credential. So every time I see this in an API, I'm like, oh my gosh. Secondly, okay, great. Let's pretend you wanted to use this capability. How would you store that and manage it in your database, in your application securely? Any ideas?
Encrypt it.
Maybe. How would you, are you talking like a hash or really encrypt?
A hash.
Okay, so you hash it. Now how do you figure out which token you want to compare the hash to? A hash of the token just becomes another token. So you have to have something to look up the record and something to compare it with.
Compare it with the hash of whatever they give you?
Maybe. So the answer that the problem is it's really hard. If you just take the credential itself and hash it, now you have to look it up somehow, and then you have to compare the hash. And so we're back to the fact that a UUID makes a really terrible password, because that's what this says about it not being hard to guess, because they're time-based. So as time moves on, the UUIDs change through their search space, and they have a constrained key search space for an attacker to search through on an order of a small amount of time. But they make awesome usernames because they're unique. So we can generate a long random password and then treat this like this. So I give you back, now my new system gives you back this. The first part's a UUID, and the second part's a secure random string. That is, so just to give you an idea of that length, 16 ASCII characters represents a 128-bit value. 32 ASCII characters represents a 256-bit value. And those are the two most common key lengths used for full partition disk encryption. So we're now talking about a search space that is not brute forceable in the known age of the universe. So this is a lot better. And then you can treat it like a password using has secure password, where that second part gets thrown away and gets decrypted. And this is a demo toy app that I invite everyone to look at. And it has an RSpec for the happy path. Again, it's a toy demo app. It's for learning. It's not don't like take it and plug it into your enterprise class system and then tell me that I forgot something. But anyway, so take a look at that. Any questions about this?
I was just looking it up on Wikipedia to confirm. Like UUIDs, I think the most common scheme these days is actually just pure random generation. They don't actually like.
They're not time-based any longer?
No, it used to be concatenating MAC addresses and time and a whole bunch of things. But like the version 4, which is what like say the Ruby secure random library uses, is just plain whatever bit random number with like a version ID stuff to the front.
Right. Well, then maybe it's better. You still have the how do you securely manage it within the database. So this sort of scheme helps with that still. But that's good news, actually.
Yeah, it's not any different from any other random anything about the same way.
Okay. Thank you, sir.
Other than the handful of fixed bits. Other than the handful of fixed bits.
No.
The search space is still smaller than a truly random number on that front.
You recognize it as UUID, but that's not all it is.
Yeah. Awesome. So let me tell you a story about when I was in graduate school. And this really helped shape my career after that point. I had finished up at Tech, and I was at Georgia State taking some classes before I ended up deciding to do information security here at Tech again. And I was in a software project management class, and that we were doing like project planning, like use cases and all that fun jazz for some web application. This is like 2006, so anyway, I had some questions like, wait a second, we have to deal with this, and we have to deal with that. And the professor, that was security related, and the professor said, Frank, in front of everyone, Frank, that is not a functional requirement. And I about flipped, and yes, he was my professor, but I was like, no, it's not that way. And I think I said that too. And the problem is he was technically right. By the meticulous definition of a functional requirement, he's right. It is a non-functional requirement. But if you take the assumption that we move non-functional requirements outside of the project scope and don't plan for them, then this is the worst advice ever. Because the security considerations have to be part of every single stage of the development process. Otherwise, all too often, what ends up happening is everyone is depending on someone else to take care of their security, and no one is. So no one takes care of security. The developer says it's Rails' problem. Rails says, sure, we got the fundamentals, but it's up to the app developer. The host says, well, we just provide hosting. We don't have to deal with this. Literally no one down the chain takes anything other than the most basic thing into account. So that's wrong. Well, it might technically be right, but don't ever take this to mean that you can ignore it. So security is really fundamentally about risks and risk management. That goes back to my second question earlier. What's the worst thing that can happen? That's risk. And you can insure things sometimes, or you can take precautions to make sure. But everything has a cost. So for instance, to the business, the CTO goes to jail might be worth spending some money to make sure that doesn't happen. We have to pay a user $10,000 to go away because they felt violated. Maybe that's an acceptable trade-off, and they don't want to do something. But again, that's how that insurance and risk management works. So here's what we're going to go over now the rest of the talk. Information classification. I actually already did the API token, so we skipped that part. Data breaches, professional ethics, and the OWASP top 10. And you should all go check out RailsGoat and don't do what it says is like how you implement your own application. So if you've ever, and by the way, some of y'all were at a previous version of this talk, and so y'all should know even more. That's good. So if you've ever been to a security talk, we like to talk about the CIA. Stands for Confidentiality, Integrity, and Availability. So if you go to Introduction to Information Security here at Tech, they're going to talk about this day one. And the other two parts of the triad are non-repudiation and non-repudiation and authenticity. So verifying that something has not been modified in transit. And something like SSL actually takes care of all those things. So that's why SSL is not only about security, it's also, from the standpoint of confidentiality, it's also about making sure that the data has not changed in transit. Another thing that security makes it hard is it's a weakest link problem. So that weakest link could be that your web application does not sufficiently authenticate connections and lets people pull up arbitrary records. It could be that your system is perfectly secure and the customer service person says, why, sure, Mr. Smith, I'll be happy to read back your bank account information that you lost. One, we got a problem that the customer service agent can read the bank account information, and two, we have a problem that they're giving this out over the phone. So it can be a people problem. Who here has heard, I'm sure, either through personal experience or watching movies like military style, like secret, top secret, compartmentalized information? Awesome. So everyone likes to talk about those, and the books on security talk about that in the sense of mandatory access control. And then on the very last page, down in the last paragraph of that chapter, they say, oh yeah, there's like commercial systems too that are a little different. And then they don't go into it at all. And this really drove me nuts as I've gone through different things, because no one talks about how can you do security when you talk about security as if it's all 100%. It's secure, it's insecure. Again, this goes back to the secure against what? So you have to deal with what you're dealing with. Georgia Tech, when I was a student here, they still have a 4-part classification system, and it's worth looking up. But this is a 5-part system I like to personally use. I wrote it based on just the things I've seen and done and copied from people. But here's a big thing to know about this. There's a yellow line and there's a red line. Above the yellow line, business owners like to think they have the freedom to decide what their system does with all these sorts of information. They only have the freedom above this yellow line. Below this yellow line is the confidential information that a customer considers confidential. So this is basically the uncanny valley of security. When you have a breach of this, you may not be in legal trouble, but people are going to see, wait a second, you have breached my privacy. Below this line is the lose lots of money and go to jail stuff. So PII is stuff that the law itself considers secure. This means nobody has the authority to decide that we don't have to pay attention. You can negligently ignore it and just store PII and not protect it, but you're required by law to do so, both state and federal. And that varies. There's a patchwork of those, but it's what's going on. And then highly sensitive stuff, encryption keys, server secrets, staff admin passwords. Like this is really the realm, this is the realm where you as a developer absolutely just need to do it every time. Like that's not even negotiable that you would design your system. This is following best practices, not storing plain text passwords, not ever, not storing your secret keys in the Git repository, stuff that we read about. So this is about, so everyone knows, is Micah here? Oh, bummer. So I use this with his permission. He pasted this on Facebook. And he said, I learned today that Airbnb auto-posts my selected favorites in Facebook. No, that's not why I clicked sign in with Facebook button. I wanted to get through the sign up faster, not broadcast where I was thinking of staying. This is a yellow line violation. And it's bad when that happens. And the thing is, people will feel a breach of privacy even when you in mouse print on like the hidden terms of service on like page 4 and like paragraph subsection 3. It's still people's reactions, wait a second, you don't have the right to do that to me. And they complain about it on Facebook publicly. So the average computer user, this is a Bruce Schneier quote, has no idea about the relative risks of sending a credit card over the internet or sending an email unencrypted or any of the other things they do. To them it's like, oh my goodness, either they are, the computer's scary, I don't want to touch it, or they are desensitized to it and they're just like, I can't fix it anyway, I'll do this. They have no idea, okay, what is more risky, what is less risky. People, for instance, will not want to enter their credit card, but really their credit card is protected by insurance. It's probably the least sensitive information they have, whereas they'll freely give up other information that's impossible to get some company to just switch out on you. So it's a problem. Trouble is, us developers have trouble with this too. Do I use this gem? Do I use that gem? What's the difference? Like, do I just store the customer's birthday in the database because the CEO wants it, because the startup needs it? I mean, golly, we want to ask people's addresses, but, is that sensitive? I mean, we have trade-offs with relative risks that are very difficult. So let's talk about data breaches now, the meat of this talk. So here's the definition of a data breach, and I'm going to read this actually. A data breach is a security incident in which sensitive, protected, or confidential information is copied, transmitted, viewed, stolen, or used by an individual unauthorized to do so. This part about the unauthorized to do so is very important. Here's why. As a matter of law, a data breach is considered to have been complete, as in totally breached, the moment an unauthorized individual has the ability to do any of these things, even if they haven't actually done it. That's the part that makes this stuff scary. It is as if someone got through the front door of this building and the law had to say that the CEO's safe was just raided because they got through the front door. Because people think with computers there's no way to prove they did it. Or if this is a case of a data breach, you have a hard drive that has been copied, and you don't know that they just formatted it and sold the computer for scrap. Maybe they copied the information, you don't know, so you have a data breach. The case where you have encrypted data, but the decryption key is in the same place. So now the attacker has both the means to decrypt the data, the key, and the data itself. So that data is breached even if it is encrypted. How many times has anyone ever dealt where someone said, oh, this is sensitive, I'm going to send you a password-protected zip file. What do they do in the next email? What's the point? Okay, I mean, both pieces of data came through the same channel. So an attacker that has the ability to access your email has the complete information needed to decrypt that data, to open that file. Oh, here's a better one. This drives close to home, but I'll say it publicly. Someone I work with that deals with certain things, they email report, and then they say the PIN code for the PDF is the last 4 digits of your tax ID. And I'm like, so it takes 10,000 tries offline. Like, okay, about 35 seconds on a modern computer to crack this password. Great. So this stuff is rampant all around the stuff. And it's like, at some level you have to say, well, I have identity theft insurance. There's things we can do individually. But as developers, we have to think about the bigger picture of society as a whole and the ethics that go into that. So that's what a data breach is. So let's talk about Georgia law. Georgia law defines personal information. So that first line below the red line, we don't have to guess. They tell us. Personal information means an individual's first name or first initial and last name in combination with any one or more of the following data elements when either the name or the data elements are not encrypted or redacted. Social security number, driver's license number or state identification card number, account number. Does that mean just a bank account number? Does it mean your account number in your system? A lawyer would have to know. Credit card number, debit card number. If circumstances exist that such a number could be used without additional information. Count passwords. So there's the password one too. So if you have a password breach, that is a PII by law too. Other laws, we have the Computer Fraud and Abuse Act that deals with unauthorized access and a whole host of others. We have PCI-DSS, which is not law, it's contract, but it's very prescriptive. It's, 90 pages of light bedtime reading. I invite you all to go to the Payment Card Industry Council's website, download that PDF, and just go to town. It mandates, is it 10 or 12 specific, it prescribes, I have it in my bag. It's very prescriptive. It is do these things. It is check this box and then check that box. Because when you have a breach, our auditor will find a box that you did not check and will then proclaim that you are negligent and can be fined for all of the losses subsequent to that breach. That is what PCI-DSS is predominantly designed to do, is to shift the risk from the banks and to the merchants, is really what it's about. But if you do these things, your system is better. It is more secure. So they're generally good, and they're required in some cases. This is something worth memorizing. So, yeah, just if you don't need it, don't ask for it. So let's talk about some breaches. Who heard about the Bitly breach back in May? Their entire database, backup copy of their database, was stolen because they had secured their front-end servers quite well. And it's been a little while since I read that. I believe that a developer account had been compromised. This happens, by the way. I mean, it's crazy. Programmers don't have good passwords, or they have emailed it to themselves or something. So anyway, this programmer who worked in the project's account was compromised. And the outsider used that credential to get at their code. And the code, of course, that didn't have the data. But somewhere in a README file or a config file somewhere was the credential to their backup system. They were then able to go to the backup system and copy the entire database of Bitly. And so it was compromised. Fortunately, the passwords were hashed. And hopefully no one was storing secret information in their bookmarks. But this is bad stuff. And so they came out clean and made a bunch of changes, including two-factor authentication and using GNU-PG for encrypting things. But that's just trying to put, the horses back in the barn after they're already out. I mean, that's a tough spot to be in. The buffer app, this one was the huge one. A customer service, so their customer service agents had access to a masquerading feature where they could connect to an account, presumably for the purpose of providing good customer service. And a customer service member had his password emailed to himself, and somehow his personal email had been compromised. The attacker was able to log in with his account to then masquerade as customers and copy out their API tokens for these other systems and then cause a lot of problems. So the lesson here really is two-factor authentication would have made all the difference in the world. If this customer service member had, in this case, had simply had a YubiKey that he had to use to plug into the system to connect, or even a Google Authenticator app on his phone, this could have been avoided. If they had stored these credentials in such a way that, customer service agents, maybe they don't need to be able to see the secret token. That, because this was a breach through the front end, instead of a deep back-end breach, like it wasn't that the database was copied, it was that the customer service function was being misused. That could have made a difference. So that's failure of not having two-factor authentication, and it's failure of compartmentalizing information such that staff members have access to only the minimum information to do their job. Humana's Atlanta breach. This one's awesome because it was so low tech. So apparently, somebody who works there went into a restaurant or a store or something and left the laptop in the car, and surprise, surprise, someone broke in the car and stole the laptop. And that maybe would have been okay because the laptop was encrypted, but for some reason they had a USB disk with unencrypted data on it. Presumably they were using to copy from the secure laptop to some other system. So get to read about this in the news about how there was a data breach with Humana in Atlanta. Oh, eBay. They lost a lot of passwords back a few.
What was the closing bid on those passwords?
I don't know. What was the closing bid on those passwords? That would be funny. Did they sell them on eBay? That'd be too common. Here's
Russian mafia.
Yeah. They did have this one's great because it's also low tech. Ruby Tuesday, the restaurant, but it had the word Ruby in the name, so I had to use it as an example. Support center staff inadvertently emailed a former employee, so I guess they were no longer there, a spreadsheet that contained employees' names, social security numbers, bank name, bank account type, bank account numbers, and routing numbers. My first question is, they had a spreadsheet with all this in it? Like, you know, the news item was like, oh yeah, they accidentally emailed this thing to these people. I'm like, they had a spreadsheet with this information in it? Like, what? See, I guess they had no security people at all. So anyway, that was a breach. Even though, notice this, that the former employee swore that he or she had deleted this email. Yep. Target had a massive breach. Big deal. Actually, it's why we're going to have chip and PIN cards next year.
Yep. So
the after that one, basically, so I don't know if anyone knows this in Europe. Let me see. I don't have a credit card with them, but I have an OpenPGP smart card. So this is an OpenPGP smart card, which uses somewhat similar technology. There's a computer chip on it, and it plugs into a smart card reader. And the way these work for crypto is it's used for crypto credentials. The way this sort of technology works with a credit card is the credit card gets placed inside the reader, and then you have a PIN pad, like your ATM PIN. And the PIN is the code to the smart card. And if you enter the PIN wrong more than a few numbers at a time, the card becomes bricked. So because it's hardware, it's actually fairly, I mean, short of some what they call fuzzing attacks, where you can cause the card to glitch by like varying the power supplied to it. They're pretty darn secure, and that's something Europe has done for a long time, and there's a reason for that. Back in France, where they developed this originally back in the 80s, phone service was really expensive, like really expensive. So the concept of you're checking out at some place that takes your credit card back in the 80s, I don't know if grocery stores did then, but whatever took your credit card, the concept of calling to online verify the account was just prohibitively expensive. So they had to set up this system. And the way it works is your card has a crypto key on it. You have the PIN. And instead of running the card number and getting the online authorization like we do here, the card digitally signs. It's almost like a check. It's like, dear bank, please pay Publix to the order of Publix, $56.12. Love Frank, or sign Frank, excuse me, and here's the signature. And so then it gets processed that way, and it's a cryptographically signed, and the bank can verify it and do that. So it's really an electronic check is the way that system works. Versus with our system, where we trust the merchant to have all of our account number information and to tell the bank, Frank said you should send this $56. Okay, thanks. And so it's a good thing. Any questions so far? Yes?
What's the requirement, I know in the target one, is it was encrypted here, but they sent it unencrypted 5 feet to the thing. That the break was in between the machine where you just encrypted it.
Are you talking about the target breach specifically?
Yeah.
They're super in-depth. I don't want to characterize where it was, but it was an endpoint compromise. And it was a persistent, almost like a virus. So it was able to stay persistently in the system and harvest a lot of account numbers. The sad part with Target is if they had had egress protection on their network, it probably would have stopped that. That's basically a firewall that looks inwards and says, you're not talking with that outside entity. Because even if the exploit were encrypted, chances are it would not have been destined to an authorized external location like their Windows Update server that's specifically Microsoft's IP addresses. It was also a breach through a trusted contractor, and so this is again an example of the weakest link thing. So even if we presume that Target's information security practices were impeccable, which is a stretch, but even if we were to grant them and presume that, their outside contractors' practices certainly were not, and that that transitive trust property is what was the toehold that led to the whole situation. So, professional ethics. This is really the meat of this. And let me tell this with an anonymized story of the sort of thing that I personally have to do. So if I'm working with a customer as a developer, and often that involves a bit of startup coaching and a lot of design and some writing of some Ruby code and databases and all this fun jazz it takes into building an application. We all do this sort of thing. If someone says, Frank, I love the little pep talk you just gave us about data breach laws and, the state of Georgia says this, but we just don't care. We've hired you to build, what we tell you to build, and we just want you to stuff it in a database, and because that's our decision to make as the business owners. I personally have to then say, if that were to come up, that I hear what you're saying, but I am not ethically able to do this service for you. That if you are more comfortable with another developer that I can help hand off this thing, that these are the countermeasures that are the only way that I would agree to implement this at all, because I am professionally, ethically obligated to not harm society just because my customer is not the ultimate authority here. It's my responsibility to the world. And so that's the standard I've drawn for myself. And I think that's the type of standard every one of us has to individually draw. It's like, what is your line that you won't cross? And for me, that's pretty high because I actually understand things like encryption and data security and stuff. So, I'm like, no, absolutely no way. But if someone came to you and said, hey, would you throw this birth date in here? Maybe you're okay with it. If someone said, hey, what sort of information do you feel that is you hurting society by building the system that's not having adequate safeguards for that information? And that's something to think about. And so now let's get into the meat. And the term is minimum standard of care. And that's used in some other industries like engineering and healthcare and other things. And it's basically, at what point are you actually being negligent? Maybe for someone else, it wouldn't be negligence because they don't have the knowledge. But because you have the knowledge, at what point are you being negligent and you can't do that? So let's talk about defensive depth. I'm just going to go through this list. So there's about 4 slides here, and it's increasing levels of technical controls that you could have in place as part of the defense in depth strategy. Never put server credentials or API keys in the source code repository. You could have a firewall, such as Cloudflare. You could have a robust web application secure development practices that do all sorts of fancy things. But notice this term here that's in bold. Just remember the term abuse stories. And I'm not going to go in deeply into these, but there's this thing called abuse cases that are prevalent in the literature. They're the evil cousin of use cases. So if we're doing Agile, when you're writing, let's say, as a user, I would like to log into the system and see my kid's most recent, activity so that I can then tell, or, as a such and such, I want to do this so that. Well, there's the evil version of it, which is, as a malicious adversary, I want to perform a SQL injection to get, and maybe that's even too technical, I want to steal account information any way I can. And I am willing to spend time and money to do this. I'm willing to scrape every page. I'm willing to look at the source code and hire people. I'm willing to do anything. That's a story. Now you got to think. Or, and so there's certain numbers of these that you can write. And then as you're developing, this informs the development decisions. Oh, wait. Someone actually wants to steal our user passwords? Maybe we need to do something more than just check the box. Look, TDD passes, we're good. I can't tell you how many times I've seen a TDD, all the RSpecs passing on something that was actually vulnerable to an attack. Because none of the test cases covered the attack. Because it was a non-functional requirement, so no one was thinking about it. It makes me so mad. Okay. need to know where employees, especially customer service, do not have access to information they don't need. Think insider threat. Database with varying levels of permissions and enforced by the database server. Oh, I love this. Okay, if I had a dream, if I could like wave my fingers and write a gem that fixed this for all time, it would be that every single controller had a different database user. So that when you have one part of the application that is compromised, because when we do Rails, we have one database.yaml. And how often is that not only a user that has full permissions, but is a God user that can like create and destroy tables and everything. It has all permissions. This is the worst thing ever from a standpoint of compartmentalization of information. And it's exactly the way Rails works. Short of that gem existing, this is a call to service-oriented architectures where each service has restricted access to the shared database so that service B that only deals with this part has no permissions to touch service A's tables. And if you have to do some things that is restricted down to the fields. So for example, maybe service B has something to do with users and users can change their passwords, but they can't get created here. So service B only has access like to update the specific fields on that table. Let your imagination go wild, but each service has its own database user, its own database YAML file, and a shared common database. And so that's the principle of least privilege. Multi-factor authentication is awesome. We should all use it and basically start making it so that any customer basically have no choice. They need to have multi-factor for their staff members. This is the perfect example of a technical control that seems exotic to our customers who don't understand. Whereas if you just say, hey, sir, here, let's set up your phone. Or, let's order these YubiKeys. They cost like $200 and we have them for everybody. As a developer, just really push that. And let's see if, within a couple years, we wouldn't have a single application that had either administrators or people who work for the company should all be multi-factor. If we can't get there with the general public, let's at least get there with the staffs of our customers and our companies. Enhanced measures. So this is below the red line. You can do all sorts of things from, I really like running Linux servers now. I don't trust most of the hosting providers after having spent time with them in their systems. I have come to not like the security of any of them. You don't have to go that route. I'm off the deep end. But one tool I like a lot is mod security. And you can use it with Nginx and you can use it with Apache. And what it does is it's a web application firewall. So you can have rule sets and you can literally stop connections from even getting to the Rails application to process. And this has been really effective. It can there's an OWASP common rule sets that you can use. And I have a project on GitHub that I'll share with anyone where the trouble is with OWASP rule set as its default is there's a handful of rules that are literally incompatible with Rails because apparently there are PHP apps that get owned in some of the ways that our Rails apps just work. Like for example, filtering out delete requests because it's not common. Oh, this is an attack, flag it. And then I'm getting reports about how people are getting firewalled because failed to ban is picking up on there. So that's to do. Encrypting records, that's something good to do. The smart cards, we can get into that later. Organizational countermeasures. This is the stuff that I was talking about, where you need to provide pushback to your employers. We can choose to use bcrypt without getting permission from a business owner as developers. We can choose to just tell them yeah, by the way, industry's practices, you have two-factor authentication. Here's your two-factor authentication. We can make that choice all today, and in 2 years we could have everyone we work with being totally multi-factored. But this is harder for us to do. And they don't have to do this all. Things like background checks, regular security guards at their buildings. So if you're a government building, you have fences and guards and So the point is, security never ends. Most of us will never get to this slide, but we need to know that it exists. And if you work with a place that needs guards with rifles and dogs, that's a different type of situation. So one thing you can totally do for yourself is make sure everyone has DoD style access cards, right? It's one good countermeasure. Anyway, that's fun. This is, by the way, the smart card, OpenPGP, and the it's a reader, smart card reader from Amazon that was like $10. So you can use encrypted stuff. So the GPG-ME gem wraps GNUPG, so you're able to add that to your project. And now when you instantiate keys, you can actually create a model, let's say, that has an accessor, an adder assessor for the plaintext, and then on its initialized calls, it takes that and it encrypts it using GPG against a key that's a private key that's never been present on the server. You can stash that into the database, and this helps you create encrypted one-way information flows when it's appropriate to do so. So this is the kind where you've tried your darndest to get the business not to collect this information. They say, nope, no way, we absolutely have to. The law says we do, business says we do. We have no way of avoiding this radioactive information. We have to handle it as secure as possible. This is a way you can do it. This is also very helpful if you are doing anything like an app for healthcare applications that has to deal with HIPAA and actually storing patient information. Remember Shamir's law, though? Basically, crypto is not broken, is bypassed. So once you encrypt something, no one, not even the NSA, is going to break your crypto as their normal course. They're going to go around it through some other means, potentially even threatening to rendition someone to Guantanamo if they don't say the passphrase. So just saying, there's a level to which you can be secure against and what to do. And encryption doesn't save you from all adversaries. So the OWASP top 10, this isn't a real practical. Okay, before we get here, this is super practical, y'all, but is there any questions?
Do you recommend adding these things like, GP and GME gem into your applications now? Or?
I have an application that's actively using it. It's one of the more, I would prefer that you, remember when we talked about you can't steal what you don't have? I would prefer to design, to push back and see if the business will change their model enough that your system doesn't even have to touch it. Often it's just someone being pie in the sky, and when you really get down to it, they don't need the information, and in the rare case they did, they could call up the person and ask specifically for it at that time rather than keep it in a database all the time. I would recommend, as a developer, learning about GNUPG. So at our company, we all have these OpenPGP smart cards. So this is actually the SIM card version of the card I showed you. And so we use this to send encrypted emails to each other, or to, if we're going to drop something in BT Sync that needs to be secret, we can do that. It's nice because you can encrypt data, put it in your Git repo if you want, and you can cryptographically sign your Git commits if you would like. It's actually a feature in Git. So
what was the application that you install with the...
So yeah, look up GNUPG. You can also, if you have Homebrew on your Mac, you can install it with brew install GNUPG, and it's PGP. So it's encryption software. And if anyone's heard to Google end-to-end, which now Yahoo is going to do as well, they are using the OpenPGP standard. So fortunately, they're not inventing their own. So those of us who have been using GPG for over a decade, maybe at this time, some smaller number of the members of the public than before will actually start to use it widespread, which will be great. Yes?
So you mentioned your dissolution with hosting providers. I mean, are you talking specifically like Heroku, AWS, or and then do you have any particular critiques?
So I gotta remember I'm also in public now. I'll give you an example. I'll give you some examples. So the question is, yeah, you can, but I'll repeat this question. There's a microphone, by the way, for this thing. The question is, I mentioned that I'm disillusioned about the security in various hosting providers. Do I have anything particularly against Heroku or AWS? Not per se. I have seen major providers where the deploy user that has all, like the web application runs as, also has sudo access to root without a password on the virtual machine. Like, yeah, let that sink in. Does anyone know what I mean by sudo access to root?
Yeah, like the user or...
That means that any Rails vulnerability is now a complete breach of everything on the Linux machine. There's absolutely no compartmentalization. Zach knows a lot of, Flip knows, I'm sorry, Flip knows a lot about, wait, what? Oh, okay.
Flip somebody.
Yeah, I know. I'm sorry, Zach. Zach knows a lot about this.
Oh man, that made me forget my question. My question was, why is this a big problem if you consider a VM as something that's like a temporary burnable machine that just runs the application code? It doesn't have like direct access to your database other than just the runtime credentials you've given it. Like in the case of Heroku, nothing else, no other daemons run on your Heroku VM except for the application.
It's assuming that you're using a VM, which Heroku doesn't use a VM.
Well, Heroku uses a Linux container.
Well, I mean...
But it's a disposable environment, so if it's compromised, why is that a bigger deal than if you had a more restricted user account running the web application? I mean, the entire box is for running that one service. Box being a
if you're using it totally correctly, that may be an adequate defense in depth strategy. Again, I wasn't specifically talking about Heroku in this particular instance. If your application gets compromised, now you have to ask, what does the application have access to? And this goes back to the compartmentalization of services. So if you have different services running different code and they have different access to the shared database environment, and you have independent database logs, if there is a breach of the application, the toe is now in your building. So now the question is, do you have a data breach or not? And that's going to go based on what does it have access to and what does it not. So if you have a single SQL user that has access to all tables and your Rails application is compromised, someone can run arbitrary code, then it's presumed that they can also steal the credentials because they can have it phone back home and upload your database.yml to them. Or they can loop back through something. So they have the potentiality of having breached your database. And so you may have to, if you are covered, have to do a data breach notification. If it is just to a service that has read-only access to one table, and that table does not contain, maybe it's a reporting daemon or something, and that table does not contain PII as defined by law, you do not have a data breach. That's the difference between if you segmented stuff and not. So, whereas if they all share the same credential, and you didn't do that. So even with Heroku, if you have different workers, all too often there's one database credential that has access to everything. You're not sitting there with the Postgres permissions carving it down. Secondly, in the case of the Linux container, you're right. In your specific case, where it's a disposable instance, that's much better. There are a lot of applications, though, that are not deployed in that way. And in those instances, I'll get to you in a sec. In those instances, let's say that you have a database server on the same machine because you were cheap and you didn't want to spend the extra money on 2 worker nodes. And you have a breach of the application. Now you have, especially if that breach means root access on that server instance, now you have to consider absolutely everything in the database breached, even if, and you can't depend on logs in that case because the logs could have been falsified or deleted. So now you have to prove that you weren't compromised, which is basically impossible. So does that help at all? Or I
can see the value in segmenting database users, and that would be awesome if Rails did that. But regardless of having that, I still don't see the value of having a lockdown user account versus a disposable VM.
Yeah. Probably just primarily in the case where you're not on a disposable VM. So, where you're on a real machine that maybe has other credentials. And then probably the in routes to being compromised are going to be other poor decisions, like maybe the private key that that user has on that machine is also an authorized key to another machine in your internal network, because whatever, probably was a bad decision in the first place, but someone made the decision, and maybe you can hop around that way. But I don't know.
So that's kind of where my question was going.
Okay.
The thing I haven't heard you exactly say. The thing I haven't heard you exactly say is that my entire infrastructure might be in the cloud, for example, and although a web server on a virtual machine might be totally disposable, and if you get, let's say you manage to get your foot through the door and get root access to that machine, there may not be anything else on that machine that's compromisable, but you have gotten your foot through my firewall, and now you potentially have access to resources that that machine has access to that weren't exposed through the application itself.
That's
presumably a web process would have to have, say, database credentials as well.
Yeah, the big pitch here is that whatever your web server user has, or like the web host user has, probably has access, very near root access anyway, and if you don't have anything else, then there's probably not too much else to take off of it, but
how will you
probably
know?
works in a badly designed system.
I was curious, how will you know if your system is secure? I mean,
security is a process. It's not a...
I mean, you can't like run an application to test to see if your application's...
There are security scanners. I mentioned Brakeman earlier. It will find kind of your dumb errors.
Yeah.
Even if it says that you're not... So again, you have to ask secure against what? To some extent, you only have to be secure enough to the random drive-by, the internet equivalent of rattle every door to see which one pops open. Yeah. And then there's the NSA Tailored Access Division. So who is your adversary? If it's the former, you're probably secure if you're just more secure than everyone else. If the latter, you've already been compromised.
Yeah, it's one of those things where, like, if somebody decides they're going to get into your system, they're probably going to get into your system eventually. Like, it's a question of time at that point, if there's...
That's what we're hearing. That's what the security people are saying now, is if they have enough money and they have enough time, that, they will get in.
If they can arrest you, if they can threaten you with jail time if you don't disclose your SSL key right now, it really is who is your adversary. And, if you have employees with laptops that are compromised at the border in some East Asian country, who knows what happens with that information then? And do they then have credentials to log into your database and whatever you have in your setup? Yes,
They don't tend to have automated attacks for kidnapping or torture and interrogation. But two minor points about Amazon Web Services. You mentioned some wariness with that. That's been my stomping grounds for a while now. One is that I haven't messed with it much myself, so I don't know much about it, but I'm fairly sure that their Elastic Beanstalk service does now support Ruby and Rails as they're containerized. Like used to be just upload a Java WAR file and then your app is running and you don't have to configure anything.
Right.
They've got that. They've got some of that for Rails now too. So it's sort of a It's a messier sort of Heroku, I suppose, or any one of these other containerized stack systems. I'm not going to vouch for it. I haven't used it.
By the way, AWS is fine. You can run secure infrastructures in the cloud. What I'm always leery about is the magical deploy your Rails application and there's no worries in the world for you. And so...
despite how cookie cutter they want to make everything, no two Rails applications are the same anyway.
Right.
But you had seem to be connecting the point about like pseudo privileged users with the hosting providers. I mean, there are a lot of Amazon images that do that. The standard Ubuntu image does that. But I wouldn't say that's really a fault of the host. And I'm not even sure it's a fault. I mean, it's a convenience that the image maintainers did so that you can get in and actually do things on this machine image you've got.
They're presuming that you're going to take care of the security, and you're presuming that they've taken care of your security, so no one's taking care of it.
If someone on your DevOps team or someone somewhere is smart, they're going to make a less privileged user that is actually the one running your application. It's not even hard. The chef scripts do all that stuff for you. And you can
you can downgrade things from the power they give you from there. The really interesting thing to me that Amazon gives you that at least provides a default from off the bat is that their firewalls let nothing in by
That's
default.
very nice, actually.
And you have to specifically say, okay, well, these classes of machines of mine are allowed to talk to these classes of machines, but not these other ones over here. You pretty much define your own network, and you have to do it all explicitly. You can still make mistakes, and still, if someone gets inside that, then they can still talk to whatever other machines they have to. So it's not perfect, and you have to really think about policy if it's more than trivial. But they give you those capabilities, and so by default, it's really hard to just get into a random Amazon box, except that they're all running as web servers. So,
well, one example, actually, you bring up the internal firewall, and this is very practical. Whether you're at Amazon Web Services or Rackspace Cloud or Microsoft, whatever your cloud platform provider, one thing to always look at is you have a database server that, let's say you have some number of your own worker nodes that need access to the database server, and they have the same or different credentials. It's a really good idea to explicitly list those at the database server's levels have a firewall, because you don't necessarily want anybody who happens to have an instance on the same data center as you to have access on the service net to your database, because that's a potential side channel if you, yeah. So, yes?
You haven't mentioned IDS.
Intrusion detection systems?
Yeah.
I did mention mod security, which is a form of IDS.
Okay, so there are a lot of different ranges of that. I mean, there's open source stuff, and I'm wondering about your thoughts on IDS. Is it something that
it is one tool in your defense in depth strategy? Okay. So you have what you do in your application, you have what you do on your system, you have what you do in front of your system, and the IDS is often that what do you do in front of it. And there's a whole class of attacks that it can identify and help you protect against. And so they're a very good tool in that chain of tools to use.
Are there examples of where IDS has prevented attacks? Because a lot of the times, I mean, you look at the target one, which that sounds like that would be something that you could potentially mark up, oh, well, they should have just used a better IDS. But I don't know.
Yes, there are successes. On the small level, I can certainly look at my own mod security logs and see malicious traffic that was blocked. There's been entire industries built up around this. The Klaus building, the Klaus computing building was named after Chris Klaus, who found ISS, and they sold a bunch of IDS services to people, and I'm sure those companies wouldn't have purchased them if it was an ineffective tool. At that level, maybe I'm wrong, but at that level, there's a lot of range, and a lot of times us or our clients we work with maybe are not going to go for, that, but you can pretty easily deploy the open source solutions or a Cloudflare in front of your application without, going. And you're right. Does that answer, it's...
Yeah.
It's a tool. The mileage may vary, but it's a good one. Does anyone know what OWASP top 10s are? So we can go through. It is the Rails code thing. So look those up. And there's something called secure headers. So this is some practical countermeasures that I want to talk with you guys about. I bolded the ones that I use without fail pretty much on all projects now. And then the others are really good ones to use. Basically, with any client now, my company is taking the approach of it is no longer the customer's option to choose. They will be an SSL-only application. There's no performance penalty to speak of. SSL handshakes happen in the order of a millisecond with a properly, a modern implementation. You turn on strict transport security, which informs the browser. So you set up SSL. You set up port 80 to immediately redirect to the SSL port. You set the HTS property, which tells all conforming browsers, which is all the current ones, to never, ever, ever until this timestamp expires, which is like 6 or many months in the future. Never talk to me again over port 80, no matter what. And the browsers will cache that result and listen to it. Then to be sure to use secure only. That's a flag in your application config file. When that happens, it will set the secure only flag on the cookies so that your cookie jar, the browsers change their behaviors around that cookie. In Rails 4, by default, you have signed and encrypted cookies. So by that, pretty much you're immune to about everything except for the attack where a malicious adversary floods the browser's cookie jar with bogus cookies in order to push your cookies out, like a denial of service attack. But there's really nothing they can do to your specific cookie for your site at that point. So that's very strong. X-frame options, that's a Nginx or Apache setting. I usually set it to deny. And what that does is it prevents the malicious adversary site from loading your site into a frame and causing that frame to do things to your site, which then allows an authenticated user to potentially. So it's basically clickjacking is the name of that particular attack. And again, that's just going into the config and saying deny if you don't ever have a reason to frame your site. And what that does is any other domain can't put your site in your web application in an iframe, and the browser will respect that. And then content security policy is pretty awesome. It's a little finicky. I wish more people would do it. It's a header where you can declare to the browser that these are the only servers that you are permitted to speak to with regards to any JavaScripts or assets coming from this domain. And the browser will enforce that. And there's some variations in different browsers, but it's a standard. It's worth looking at. And it's finicky because people like using like their Google fonts and stuff. So now you have to tell them, okay, you can talk to Google too. And oh yeah, there's that chat widget we had. You can talk to them as well. So that's why people avoid it. But if you have to lock something down, this is a good countermeasure. So this is kind of in the realm of what you can do. So again, this is now to the floor. Yes, ma'am. Yes. So if you set a secure-only cookie, then the browser will not relay that cookie back to the non-HTTP site. One of the reasons that is very important that's helpful is, and this is less of a problem with Rails, depending, because the cookie's encrypted. So, but if you don't, the problem is in a connection downgrade attack, where if someone has logged into your secure site, and even if it's not an attack, let's just say they've logged into your secure site and you set a cookie and you didn't set secure only, and now they go away, and now they're at their favorite coffee spot that's being actively monitored by an adversary wanting to steal cookies, like a fire sheep attack. And they type in your website again, and it goes to the non-encrypted page. It goes to HTTP. And in your site, because it's not the login page, like this is the old way, like Spree does this. It's not the login page. We don't want to be an SSL site. What now happens is their browser relays the cookie over an unencrypted connection. And when that happens, now the attacker can copy that cookie, and if it's a session cookie, they can now use it to access the person's account because they've already been logged in.
But if you're never serving non-SSL content,
then that's not a problem. But this was the instance where you were serving both, and you were not using a secure only, then this would be, if you're using secure only and you're serving both, then the browser won't repeat it to the non-encrypted site. But if you're using secure only and you're doing that, now you're basically in hog heaven when it comes to this particular range of attacks. They really become heavily unfeasible for an adversary to carry out. There's still active man in the middles, particularly if they can forge a certificate So again, I liken back to adversaries that are able to use subpoena power to compel other parties to do things on their behalfs, or can use their own certificate authority to issue a certificate. And actually, that's the biggest question with the Lava bit is why didn't the FBI do that? They had avenues to man in the middle Lava bit, but it wouldn't necessarily be clandestine. They wanted him to just turn over the key, and the owner of the site, because of his own beliefs, said, no, I'm shutting down the doors. Like, there's no way I can be complicit in, allowing passive surveillance of my users to whom I have promised that their communications would be secure against this sort of thing. Yes. Yes.
Just a quick question about SSL everywhere. Does that have any kind of a negative impact on, say, caching proxies or CDNs and things for static content?
Depends on the CDN.
Frank, you may just want to repeat the question.
Oh, okay. The question was, does SSL Everywhere have any impact on HTTP caching proxies and CDNs? If you have your own CDN that provides you services through your SSL, no, because it's kind of in a trusted relationship. For proxies that you do not control, the answer is yes, absolutely. It disables them. And it's interesting to think about that Google has just come out and saying that they're giving an SEO boost now to any site that's SSL only. So Google is trying to encourage sites to go this route. And the question is it about the security, or is it about having that extra authenticity of like the content, or is it about getting rid of caches in the middle that maybe were muddying the content?
Yeah, I mean, if they're obsolete these days, they're obsolete. I was just curious if that's where things are going.
Or they may sell certificates.
Yeah, that's another possibility too. He said, or they may sell certificates. So Google's like, you should have SSL in order to, well, okay, so about certificates, there's a couple of approaches you can get them. You can get them for cheap, or you can get them for free, or you can pay a lot for them. But really, they're not so expensive that should be a problem. I usually buy mine if I'm going to through ksoftware.net, which is a Komodo reseller, because then I go through him, get the 1995 SSL certificate, which has a free upgrade to extended verification because of a promotion that Komodo has been running for years. For that channel. So I get EV certificates for $19.95. Yes. ksoftware.net. Mitchell Vincent is a person I knew from the shareware industry back in the day, and he became a reseller at some point and has created this great loophole into this. And the other source, if you want a totally free certificate, though not EV, is StartCom. The only complaint I've heard about them, is it StartCom? I'm remembering correctly?
StartCom is the name of the company. I think StartSSL.com is maybe the domain.
Right. The only complaint I've heard back when the whole Heartbreed happened and 17% of all websites had to revoke their certificates, people were howling left and right that, how dare StartCom charge us $20 or whatever it was for. So they give you the certificate for free, but they charge for revocation. And you know what? You knew those terms when you signed up for your cert.
It's also worth pointing out that apparently for the month of August, their staff is on vacation. And they shut down the website.
Wow.
I went at 11:30 a couple nights ago to go get an SSL cert for something, and it was like, sorry, we can't serve your request right now.
So right now, the 1995 is sounding like a good deal. So it's good to have options. Yes, sir.
Okay, so comment and then a question. If you go to your favorite brewer of caffeinated beverages and get on the free Wi-Fi provided by Comcast, they actually do that. If you are browsing unsecured websites, they will inject ads into your page response to monetize that free service. And it drives me crazy. Can't imagine anything worse to give to favorite Big Brother cable company. But it doesn't happen, of course, on SSL sites. That
right.
Wouldn't be possible. But my question is, you mentioned at the beginning that you sort of automatically require at least 10 character passwords, and you're right, I would probably hate that as a user. But if I, as a user, if I'm going to some I've signed up for some stupid web service that lets me post silly cat pictures.
Okay.
That's what every website does. As a user, I don't really feel the need to protect this with NSA-grade security. So I find it frustrating when a website does dictate you have to use a password of at least this bulletproof grade. So where does the onus fall on, is it the user's responsibility to pick a password that's sufficiently secure? Or as the website owner, can you say, you should have a password this strong, but if it's not, that's on you to pick something that's not, if you want to do something not secure, that's fine.
So the question is that for some random podunk website that as a user interacting with, that I don't really value the information, it's not my bank, it's just some forum for cat pictures. And I want to post or see some cat pictures. Sound familiar? It's a good sounding project. But when it tells me that I have to have a minimum 13-character password, I'm like, what are you talking about? I don't even use that for my bank. Why are you, the cat site, requiring me to use this strong password? And whose onus is it? Is it the cat site owners, or is it the user to make the choice for themselves to have an insecure password? And that's a real tough one, because I hear what you're saying, and I've had this discussion before in circles saying that the libertarian answer is let the user choose for themselves. Passwords are so fundamentally broken that if we were doing a cat website, maybe I would relax that. But here's where I wonder. Are we the first, for that user who uses the same 6-character password on their bank and every other website, are we the first website that said, wait a second, your password is not secure enough? And will that make them think, but I use it on my bank. Why are you, the cat site, telling me that it's not secure enough? And would that slowly make you rethink or make a change? And that's my hope, is that we're encouraging better security practices everywhere rather than just protecting our site, our cat site passwords.
And as a user, it's probably impractical for me to remember a different password for every service that I use. And there are, 1Password or tools like that. I don't know if those are any more valuable, because now you're just putting all your passwords under one giant password anyway. So that may be a vulnerability. But I tend to take the approach of levels of passwords. For stupid stuff, I use a stupid password. For secure stuff, I use a secure password. And I'm kind of picking the complexity of my password based on how much I value the service.
Well, that just means all your valuable services are going to be compromised together.
Yeah, that's what I heard too.
Someone has to steal your phone instead of hack that website.
Potentially. So let me repeat the question real quick, and we're going to have to wrap this up. So the question or assertion is that, okay, that's wonderful, but as a user, it is impractical for me to remember many passwords. I prefer to have a tiered password system. And yeah, I've heard about things like 1Password or LastPass, but isn't that just putting all your passwords in the same same place where they just get compromised there? Does that sum it up reasonably well for, okay. This is the classic thing where security is about trade-offs. And the question is, which of these security vulnerabilities is more likely to take place? Both are bad. If I use the same password everywhere and I'm part of the 1.2 billion password breach, then I'm really hosed. If that is, because I've used it everywhere, and there's a decent chance that my accounts are going to be had at some point. If I use a password manager and I have 50-character random passwords I can't possibly remember for every individual site, even the cat site, because who cares? I click the button. Then if one site is compromised, it really affects nothing else. But I've traded that for if my password vault is compromised, it's a bad problem. And so the answer to that for me kind of thinking about this is that may well, for most users, that's probably the better trade-off, because it's either on your computer or on a LastPass, in the example, they encrypt it before it goes to their server for syncing, and because they're a security company, they have to pay a lot more attention to that than random websites with their own password management practices. And because I now only have to have one, I can focus on a really stinking good password. I mean, I'm talking 35, 40 characters, like, you know, poetry, and that I can just like type off, and maybe even use a YubiKey for my. So it's people are calling that. Now, I've heard it was like a marketing phrase like on the radio, but I thought it sounded pretty cool. They're referring to that as personal two-factor authentication. You know, that you had this password manager that you're using in that way. And to me, that's the better trade-off than trying to Java.
There's always the XKCD formula too. Just pick 2 or 3 random words.
Staple horse, some battery, something. Yeah.
Just pick 3 random words. You get much better entropy than, you know, just.
So that is true unless the attacker knows you use that system. So that's based upon the presumption of length. So if you think about Shannon entropy, which Claude Shannon had like the information theory for how many bits of entropy does a particular password represent or piece of data. If you have an 8-character string, it's a lot less secure than a 16-character string. 16 characters is 128 bits of potential entropy. But if the attacker knows that you're using passphrases, then now the words in the dictionary become the new characters. So you just collapse that set. So the search space can be, I try apple, bird, comma, instead of, but yeah.
60,000 cubed is still a lot.
It's a lot.
It's a lot. It's down to the dictionary then.
Yeah. So no, most people are absolutely, I use passphrases. Like, there's no question. It's the better way to go. So.
One more thing about one password for your password keeper, where someone have to type in all of those over and over on your phone or whatever.
Yeah.
So 1Password actually says on, if you read their FAQs, they sort of talk about it as like a 1.5 factor authentication, meaning you have to know something, which is your master password, and you have to have something, which is your password vault, right? So your password vault in 1Password, if you set it up, it can sync over Wi-Fi, so it's only on your home network. So as opposed to using the same password on all of your services in the cloud, it's a lot better because they don't, you know, they would have to have your password vault.
Yes. I think that's about it, guys. Okay. Thanks.
This video has been sponsored by Rietta Incorporated. Learn more today at rietta.com.